Hi gents, today we're going to have a quick look at question 7 there from your mocks. Thank you for those who got in touch just requesting it and pointing out that I'd probably missed it. Looks like I just missed it as I was going through it. So let's have a quick look at it. It says tidal waves or tsunamis are the result of earthquakes in the seabed. The speed v is directly proportional to the square root of the ocean depth. So they say v. Now v is the speed or the velocity, and it's equal to k, where k is just a number that stays the same by the square root of d, where d is the depth of the ocean. Okay, d is the depth. Okay, now let's just explain. V and d are variables. The speed changes depending on the circumstances. The depth changes also depending on where you are inside the ocean. But k is something that stays the same the whole way through. So what they're going to be doing here is, in order to be able to get k, they will need to give us both the speed and the depth. If they give us that, then we can work out what k is. And then once we know what k is, they'll probably give us the speed and where you have to work out the depth, or they give us the depth and we have to work out the speed. So it's just like a function, really. So they do give us that in the A part, and I'll just label it as A here. They say given that a tsunami is traveling at 9.8 meters per second, so they're giving us the speed, so we just fill that in. K we don't know, but they will give us the depth, I'm sure. And an ocean depth of 10 meters. So there you go, they're giving us that. And they're asking you to show the K as a particular value. Well, how would we get K here? Don't square both sides. That might seem like a good idea to get rid of that. It's not really. What we have here is we've root 10 by k equals 9.8. So it's like, you know, if I said to you we've got 5k is equal to something, what would you be saying? You'd be saying, okay, we divide both sides by 5. So applying that sort of logic over here, you should be dividing both sides by root 10. So root 10k divided by root 10 equals 9.8 divided by root 10. So there we go, we've got k is equal to 9.8 divided by root 10. Now we were told that this is what it will be to one decimal place, so if we actually type that in, 9.8 over root 10, we do end up getting to one decimal place 3.1. So that's what k is, and what we should do now is, I think it's a good idea to change it. Change the function, not change it, update it, I suppose. So there's our speed still, and our d is our depth. It's not root d is our depth, but d itself is depth. Okay, so now they're either, you know, there's only really one way to do this. They're either giving us the speed, we get the depth. They give us the depth, we get the speed. Okay, so in this one it says find the speed of a tsunami at an ocean depth of 3 kilometers. So they are giving us the depth. So we can just say here, this is B part, V, find the speed when the depth is that. And they're asking us to get this to the nearest whole number. So 3.1 times root 3. The nearest whole number there is 5, because it's 5.36. Don't forget to put in the units. It's meters per second. K was just a constant number, there was no units attached to that one. We'll do the C part. Find the ocean depth. So they're going to give us the speed here, we can tell already, where a tsunami is traveling at 1 meter. So we fill 1 in for V, 3.1, and we're trying to get root D. So what should you do here? I think the best thing to do here, you just want root D on its own. Best thing to do is divide both sides by 3.1. Because that will leave you with just root d right there, and on this side you have 1 divided by 3.1. I suspect that that's not the nicest number the world's ever known. It's not, so I think we'll just leave it at that. We'll just call it 1 over 3.1. and now to go from root d to d, okay, to go from there just to d, you would have to take root d and you would have to square it. So you just do the same thing there, square both sides. So we get d is equal to, and we'll take that number and square it, again asked this time 1 decimal place. Now I wonder, did I quite do that right? 1 divided by 3.1. Get that, and the answer squared is this. I did mistype it the last time, sorry. So it's 0.1 is what it is. And we should just say, what's that being measured in? Meters. 0.1 meters. Does that seem right? It does seem to be, yeah. So just looking at it there, now that I've paid attention to the units, I have fallen into a classic trap there. Look at that, appalling. Everything that they had there was in meters, and what did B say? B said it had a depth of 3 kilometers. So look at that, they're out to get us. So actually that would be 3,000. Look at that, so easy to miss stuff like that. So just make sure that that you do double check units, all that sort of stuff. So 3.1 times root 3,000. Let's get the actual one. So what was this? This was to one of the first whole numbers, so that was 170 meters per second. It was 169.79, so the nearest whole number 170. Okay, I wonder, will they have any other mean tricks like that? No, I don't think so. Okay, we'll go on to the D part. Just reminding ourselves that it's V, pardon, is equal to 3.1 times root D. It says the fastest tsunami ever recorded was traveling at 790 kilometers per hour. Now look at that. Look at that. When we were talking about the speed, when they talk about V, they're talking about meters per second. But in this case, they really are trying to trick us. It's 790 kilometers per hour. So we're going to have to change this into meters per second. So the first thing that I would do is I would say, okay, it's doing 790 kilometers per hour. How many meters is it doing per hour? So it's going to be doing more meters, obviously, and you multiply by 1,000. So that is how many meters it does every hour. It's funny, sometimes people, they're like, do I divide by 1,000? Do I multiply by 1,000? Just think about it, okay. If I'm doing 790 kilometers, am I doing more meters or fewer meters? And clearly you're doing a lot more meters. So you're multiplying. That just is maybe just a little shortcut way if your intuition isn't great. Okay, that's how many meters it does every hour, but we want it for every second. So again, you can do sort of do that little just check in your head. Okay, if I'm doing that every hour, what would I be doing every second? And of course I'm doing less. So we would take 79000 and divide it by 60 to go from hours to minutes, and divide by 60 again to go from minutes to seconds. So it comes out as, it's kind of best written as a really it's best written as a fraction. 1975 over 9 meters per second. When you divide by 60 and you divide by 60 again, what you're really doing is you're dividing by 3,600. That's a little shortcut for you. How do we figure that? When you divide by 60, you're really multiplying by 1/60th. You're getting a 60th of it, and then you're getting a 60th of it again. So when you multiply by 1/60 and by 1/60, 1 by 1, top by top, and bottom is 3,600. So you're really multiplying by 1/3600, or you're dividing by 3,600, whatever way you want to think of it. Okay, that's the value now that we have to put in. We're given that speed here. We're given that 1975 over 9 is equal to 3.1 times the square root of d. We divide both sides by 3.1. So 1975 over 9 equals, divided by 3.1. not the nicest number the world's ever seen either. 19750. I mean, just do it on your calculator, it's not a bother. 279 is equal to root d. And to get d, like we did beforehand, we just take our answer and square it. Okay, so it's 5,000. Now, what were they looking for here? Give your answer to the nearest meter. So that is 5,011 meters. Okay, so that's the fastest tsunami recorded. Okay, the next part here is them saying complete the following table and hence draw a graph to go with it. I can see why people were asking about this. I'd say the issue was units. As you saw, I did fall into the trap momentarily. So just one to keep your eyes open for. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what they're doing this time is they're giving you the depth and they're asking you to get meters. So remember it was, or they're asking you to get the speed. It was 3.1 root d. So you've got a choice here just on your calculator. You can just blast it all in, but this is a perfect time for you to just remember how to use your functions or table function on your calculator. So if you were to say, you know, d is like your input, you're inputting 0, 1, 2, etc. and v is going to be your output. So you could think of it as y is equal to 3.1 times root x, just for your calculator. So if you've got your FX85 GTX, we can use that there. I think most of us have that. So if you go into the table, if you create a table and it says f of x equals or y equals 3.1 and you do alpha and x, that's the closed bracket on my calculator here, but it's not alpha x, it's alpha root x is what I should be writing in. So root x, press del. In this case, on this calculator, then says g of x. We don't want to do a second function. And we want to start here with 0. We want our end one to be 9. You press equals after each of those and a step of just 1. So it then creates a lovely little table. So it says 0. And what was this? Didn't ask us to any particular following. Yeah, no, it didn't ask us to any decimal places or anything. 3.1. I'm just going to do it to one decimal place if that's okay. 4.4. 5.3. Actually 5.4 is what it's closest to if we round. With 4 it is 6.2, 6.9, 7.6, 8.2, 8.8, yeah, and last one 9.3. And it just asks you then to graph it, okay? You can graph it, there's no problem. I'm not so good, as you know. So you've got meters down here, depth, you've that here, meters per second. And you would start at 0, 0, and when you move over 1, it goes up to 3.1. When you move over 2, it goes up to 4.4, etc. Draw it in. It asks, is it a linear function, and why? So once several reasons, one could give several reasons why it's not. It's not a linear function. Because it's not going to give you a straight line when you graph it, which you'll see when you do graph it. But let's just also talk about what it would be. When we move up by 1 here, when you move over 1, this is going up by 3.1. But when you move over by 1 again, okay, we've just moved over by 1 again, going from 0 to 1, 1 to 0. In this case, it's only gone up 1.3. Okay, here it's only gone up 1. So what we're seeing is that first difference is different every time. Okay, if it was the same every time, it's linear. If the second difference is the same, we know that it is quadratic. I'm sure you remember that from before. Okay, so that's that question. It was, you know what? It was straightforward and tricky all at the same time. Just you had to really keep your eyes open for it. Um, Thank you for getting in touch, those who have been, and just to say as well that I'm going to have a chat with the other maths teachers. We're going to decide what the best way to proceed is, so that it's fair on everybody. Okay, gents, take care. All the best.